So yeah, my name's Dan Davydov. I've been working on Airflow for about 4 years now. First for ETL infrastructure at Airbnb with Kevin actually, and now at Twitter for machine learning infrastructure. And my talk is going to be based specifically around how we use Airflow for machine learning at Twitter, but a lot of the information will also be relevant for non-machine learning use cases. So first, I'm going to talk a little bit about again how Twitter uses Airflow for machine learning, and then I'm going to talk about some of the pain points we've had with a specific focus on machine learning, and then I'm going to be talking a little bit about the future of Airflow at Twitter and how we're going to be planning on using it in the future. So we have about 400 DAG files, 30 customer teams, and most of the use cases are ML, which is what makes Twitter a little bit unique in its adoption of Airflow. A lot of other companies that I've seen, they've adopted Airflow for ETL use cases and then kind of added on the machine learning use cases afterwards. But Twitter has always been focusing on like the machine learning use cases first for Airflow and then added the ETL ones later. So this is our current stack for machine learning pipelines using Airflow. I do want to note that we're migrating from like our previous Aurora Meso stack, but we already have kind of production pipelines running on the stack. So I'm just going to talk about the new stack. So we use Kubernetes for kind of our platform and resource, containerization platform and resource management solution. We use Google Cloud Platform for storing our actual models via Google Cloud Storage. We use TensorFlow for our machine learning libraries, and of course, we use Airflow for the actual machine learning pipelines to actually train and deploy the machine learning models. So I'm going to talk a little bit kind of like what a typical machine learning Airflow pipeline looks like at Twitter. I do want to note that this is kind of like a prototypical example, but one of the reasons Airflow has been so great for us at Twitter is because of the ability to compose different operators. And there's a lot of different types of these pipelines that our users build that look very different from this. For example, we have users using Airflow. They have operators that basically wait on Jira tickets to be resolved before the pipeline continues, and all kinds of like interesting stuff like that. But I'm going to talk about like the prototypical pipeline to keep things simple. So first, what we have is our ETL job that is going to generate the training data for our models. So there's some set of operators for that. Then once that is done, we actually train the model with that training data. That's another operator. Once that's done, then we have an operator that will basically launch a prediction server using the trained model. And then it's going to be kind of this like temporary server we set up and then we later tear down. And we actually send requests against the server to make sure the predictions that are generated are correct. And once the model's been validated and tested, we then push the model to a location to get picked up by the production deployment system. So I do want to quickly touch on why the production model deployment system is not inside of kind of like the Airflow pipeline itself. And actually not even just production model deployment, but any kind of artifacts that you want to deploy out of Airflow, why it might not be the best idea to do that inside of Airflow. Airflow isn't really designed for artifact deployments in the sense that there's the systems that are kind of are specialized in doing these kinds of deployments. They offer features like rollbacks, all kinds of special metadata, and UIs that are very tailor-made to this use case. Whereas Airflow, it's a little bit less conducive to accomplish these things. And it's our Twitter's production model deployment system is in-house. It's an internally built one. And what actually ends up happening is that model, just in case it's not clear, that once the model is deployed, the purpose of this system is to deploy the model to production. You scale it up, you have like some number of servers that you want to deploy to serve production traffic requests. Now I'm going to talk a little bit about Airflow pain points that we've had for machine learning use cases. So one of the big ones is development speed. So a lot of machine learning practitioners are used to using notebooks for their kind of development environments. And if you think about kind of like a very simple example of how a user might iterate on a notebook, they'll type in some Python code into a cell, they'll run that code, And if there's some error, they'll just go back to that cell, tweak the code, and then rerun that cell. It's a very lightweight process, very fast iteration, not really any bottlenecks. Now, if you look at the same kind of example of Airflow, I'm gonna even just tweak it a little bit just to kind of highlight some of the issues. What could happen is, let's say you have some DAG and then you want to make some tweak to that DAG, but in a separate file. So you copy that DAG, you change the parameter that you wanted to tweak in that DAG. Now you want to actually run that new DAG. So first what you need to do is you have to wait for the web server to pick up your DAG. And that can take some time because the web servers have this, Airflow is inherently very like poll-based, both the schedulers and the web servers. So it takes some time for your task to even appear in the Airflow UI. So once that your task or DAG actually appears in the UI, that's when you can click the trigger button. And then after some period of time, once the scheduler picks up your DAG, it'll finally run it. And then you can click into the task instance log and look at the output. And that's a lot more heavyweight than the notebook solution, so it's already kind of like a uphill battle. And Airflow is great for production use cases, whereas notebooks maybe have some gaps in that space. But it can become a hard sell to machine learning practitioners, like, hey, you should use Airflow, when a lot of times they'll perceive that it adds a lot of overhead without actually providing value in the short term when they're iterating. Yep. So another kind of issue we've seen is some of the kind of clunkier interfaces with Airflow. So I'm going to talk about specifically XCom here. But it's, as a machine learning practitioner, I might want to do something like a very simple thing I might want to do in my Airflow DAG is train a model and then push that model somewhere to test it, for example. And how you would do that in Airflow is using the XCom system. However, XCom isn't really built for this use case in mind. So there are other alternatives like TFX pipelines, which I'll be referencing a little bit later in the talk as well, that kind of treat these artifacts that are generated by operators, whether that be some kind of data that's generated, like an HDFS table, sorry, a HIVE table, or like a trained model as first-class citizens, and they'll actually automatically generate kind of a key for or a path for that artifact. You don't have to generate it yourself. That's unique, and it's you don't have to specify like this key manually. You might make a mistake. There's no kind of static analysis in Airflow, so if you might XCOM push one value, XCOM pull another value, and you won't even know until you run the DAG. So just a lot of these interfaces are kind of like not super intuitive. Like, what does XCOM push? All I really want to do is push an artifact from one operator to another, just like calling a function with an argument. So yeah, I highly also recommend checking out my colleague Gerard's talk on his new functional DAG API that removes a lot of the boilerplate, for example, from XCom. And I think it's definitely going to be the future of writing DAGs, the language used to write DAGs. So now I'm going to talk a little bit about the tooling integration with Airflow. So what I mean by this is, if you're, again, for ML practitioners, they use notebooks, and in the notebooks, a lot of, you can basically get these visualizations that come for free with your cells that will help you visualize, for example, the training data, and you can look for anomalies or issues with the training data. Now with Airflow, you can't really do that. So you can run the task, and that task might generate some training data, but if you want to actually visualize that data, you might have to basically write some kind of custom extension, maybe link to that in the task log. It's not a very like integrated first class experience. And I do think there's a lot of these issues that I'm talking about. I think they can be solved in Airflow. So for this one, for example, if there was an ability to create per operator kind of UI widgets, so that you can imagine in the Airflow UI, you click on your task, and you can basically just view these statistics, and that's just defined in the operator definition, what statistics to display and how to display them. But this is also something that our users kind of complain about sometimes. Another issue I want to talk about is kind of the lack of open source machine learning operators. There aren't any like TensorFlow operators or uh, anything like that that are, come with Airflow. You have to kind of build your own, and you have to maintain them. Whereas there's other, again, pipeline and orchestration solutions that come with a whole ecosystem. So TensorFlow Pipelines comes with the whole TensorFlow ecosystem that comes with the TensorFlow components, which are the equivalent of Airflow operators that are already kind of can already be used to train the models out of the box. So I think this is also an area where Airflow could potentially improve in the space and add some first-class operators for machine learning. The last thing I want to talk about is it's kind of not immediately clear how this is related to machine learning, but and rapid iteration for machine learning practitioners, but it's actually the lack of secure multi-tenancy. So Airflow does have multi-tenancy. You can't have a scheduler and have different teams add their DAGs to that scheduler. The problem is it's not really possible to do that in a secure manner. Users will be able to basically modify each other's or launch tasks as like different service accounts and impersonate each other. At least that's possible in the current Airflow implementation. So why this is a problem is you kind of, if you care about security, what will end up happening is you usually have kind of like isolated setups for developer iteration. So each developer will have their own Airflow instance, like a scheduler, a web server, a worker. And that can be a problem because setting all that up ad hoc can sometimes take a lot of time. Again, comparing to the notebook example, a user creates a new notebook and they're done. Whereas here, either you have to have some team that creates tooling that will set up the database and the scheduler and et cetera for the user, or they have to use a local instance, which might also have issues like there's lack of parallelization for if you're using the local executor in Airflow. Yeah, so that's kind of another issue, like just the lack of having being able to have one Airflow cluster and having different users share that cluster in a secure fashion can actually impede development as well, development speed. So now I want to talk really quickly about kind of what we're envisioning for the future of Airflow for machine learning at Twitter. So as I mentioned, I think we've seen a lot of advantages in some of the pipeline abstractions, like the TensorFlow pipelines that are kind of coupled to this ML ecosystem. But we really value Airflow for kind of its like reliability and stability in production, and its ability to kind of serve as kind of like the execution and orchestration layer. So what we're thinking of doing, and I do want to caveat this with, we're very much in the prototyping and design phase, so nothing here is concrete. I did think it would be very valuable to share anyways, because I think a lot of different companies are kind of wrestling with a set of problems right now of how to do orchestration for machine learning pipelines. So what we've kind of envisioned is being able to take the abstractions from TensorFlow, so that would be the equivalent of an Airflow DAG. So instead of using Airflow DAG, you would use a TensorFlow pipeline, and your users would be building that in the context of a Jupyter notebook. And then the actual execution and orchestration would be handled by Airflow. So your notebook would basically take this abstraction, send it over to Airflow. Airflow would convert it to a DAG, and TensorFlow pipelines, for example, already has support for using Airflow as the execution layer and orchestration layer. So that shouldn't be too hard. And then actually handle like all the parallelization and the retries and the UI visualizations, things like that. And then also when you're ready to productionize your pipeline, what you can do is you can publish this notebook as some kind of artifact, and once it's published, they'll have a schedule just like your Airflow DAG does, and again, you would be using Airflow as the kind of execution and orchestration layer to actually run these production pipelines. Cool. That's it for me. I'm going to be handing enough to Tao at Lyft now. Thank you.
Hey, so today I'm going I'll talk about Airflow at Lyft. So here is a bit of intros about myself. So I'm an engineer at Lyft Data Platform and Tools for about 2.5 years now. So I'm a Airflow committers. At Lyft, I'm working on different data products, mainly Airflow and Amundsen. Amundsen is an open source data product. So previously is working at LinkedIn and Oracle. So today, here is the agenda. So I will be talking a bit about data platform in general at Lyft and what's the role of Airflows in the data platforms. Then talk a bit about selectively about some of the customization we have done for Airflow at Lyft. And then talk about what's currently the projects that we are working on. Lastly, a bit of intro, retro and summary. So data platform at Lyft. So for those who don't know, Lyft is a ride-sharing company. So the mission of Lyft is to improve people's life with the world's best transportations. In order to fulfill the missions, our scientists and data engineers were building different data models and data sets to understand different user behavior and to provide the best data-driven decision leveraging our data platforms. So what's the Lyft data platform look like in high levels? So two typical scenarios. One is the mobile app. Like, for example, if the user in Lyft platform could be a driver or rider opens the app, different message will immediately send to our event pub subsystem. Could be based on different scenario. Could be sending like the users drop off locations, pick up locations, etc. Another scenario will be like backend services sending messages based on different cases. To all these messages will send over to our event pub subsystem, mainly Kinesis and Kafka. And there our streaming ingestion layer will persist all this message in and materialize into our event hive tables. And then our data engineers will leverage Airflow as orchestration layer and building different derived data sets based on event tables and materialize into a lot of derived table for other consumers like data scientists or research scientists using like a lot of different BI visualization tool like Amundsen, Superset, and Mo to do data explorations. So as mentioned, Airflow at Lyft is mainly using as the workflow orchestration layer and not for computations. It provides reliable and stability. It integrates with different computation platforms. At Lyft, the main computation platform remains as Hive. And for Presto, used to be the main ad hoc query engines at Lyft, but recently it has been evolved as another ETL options as well. And Apache Spark has also evolved as another third options for computations. And Airflow also integrate with like the machine learning platform called Learn at Lyft. And also Airflow has been used for different use cases, like if the different user or services have their own Kubernetes platforms, they could be integrated with that. So as it could integrate with Druid. So this is the current usage for Lyft. As of today, we have about 1,200 DAX. Like I checked our dashboard, we have daily have around 4,500, almost 4,500 DAX runs, and daily task instance is about like 72,000. As of today, we have two main clusters. One is very close to upstream, like 1.10 point something versions. The other is a legacy ones. It's a lot of both of them are still running on Celery executor. So next, I'm going to talk a bit about some of the customization we have done for Airflow at Lyft. First, UI auditing. So as mentioned, we have two clusters. The old cluster is still running on the old UI framework Flask admin. So so for that UI, so sometimes it's pretty confusing. Like a lot of users have been question sometimes we questions like say why my DAG got turned off and I don't notice that. In order to check that, we build a UI auditing framework to check all the UI actions, so that could help to answer these kind of questions. Second, DAG dependency graph. So at Lyft, we're not only interested in the within DAG task dependency, we also interested in cross DAG dependency. And we mainly leverage at Lyft, we use two main sensors, like Lyft, the external task sensor and the high partition sensor. And we leverage the plugin to build a cross DAG dependency graph. So extra link. So at Lyft, we are a big fan of adding more information to different operator based on different contexts. Take this as an example. This is a high operator task. So we're using extra link to link different extra UI. For example, we want to provide, like say, a user to quickly one click to go to see their query log that is issued by this high operator task. They could also view the Dr. Elephant, which is a performance tuning UI tool, to see the performance report by the high query issued from this operator. Also, you could connect to like the job analysis dashboard to have a more detailed analysis for the performance, like how much data it has been read, how efficient it has been doing, so on and so forth. So Airflow has been used to build a lot of data set at Lyft. Sometimes it's a bit hard to say for a given table, different data set, which task has been scheduled. So at Lyft, we built an open source data portal project called Amundsen, which is solving the data discovery. And we built a lot of integration between Airflow and Amundsen. For example, inside Airflow, when you click the open task instance UI panel, you could directly see the Amundsen table link, and directly you could go to Amundsen page. While if you go to the Amundsen table page, you could see which task is producing these data sets. This helps users to say if they don't have any knowledge of Airflow, but they know the data set has been data quality or data issues, data delay, they could go to the DAG to see what's going on. Currently, the project has been used by many different companies in that industry. So next, I'm going to talk a little bit about the current focus for Airflow at Lyft. First, it's called ETL Expiration Systems. So Airflow has been deployed and running at Lyft for about 4 years for now. Lots of ETLs are not very well maintained and with no clear ownerships. So all these ETL could be still running in production, but no where owner is maintaining. It could be like the owner already left the company. So we have built a ETL expiration system, which it will disable the DAG with expired TTL. So it means like the DAG owner actually need to renew these TTL tokens every 6 months. Otherwise, our ETL system will disable that. Also, if we will disable those DAG that produce unused data set. For example, if even the DAG has been running, but it produce data set that no one is using. These are costly and inefficient. Lastly, so if the DAG has been failing for a long time, we also disable that. We will send email to owner first to do some warning, but if no action is taken, we will disable. Second, we are working on Python 2 to Python 3 upgrade. Hopefully, most of the people here no longer need to deal with that. But as some of you may know, like Python 2 is official end of life. And unfortunately, our legacy cluster is still running on Python 2, and with a lot of P0 dataset as well as execute dashboard is running on that cluster. To minimize the user impact, we design a lot of things to help to do the migrations smoothly with no user impact. First, we upgrade our DAG box, which is used by the user to do development DAG, to Python 3, and make sure all the new DAGs need to be Python 3, Python 2 compatible. Then we have a CI test on our DAG repo to make sure both DAG, the DAG could be compiled and loaded in both Python 2 and Python 3. But a lot of times the Python 2 to Python 3 upgrades errors only happen in run times. And those errors is hard to catch in daily because a lot of times those production data is not available during the development or testing phase. By doing so, we develop a fallback solutions. So we use Celery. We add a fleet of Python 3 workers coexist our Python 2 workers. So our scheduler will first schedule some of the tasks into Python 3 workers. If it fails, the scheduler will mutate the task queue, Celery queue, and send it over to Python 2 workers. In the meantime, it will send events to our messaging system to talk about like which task of a DAG has been failing by what stack traces. And we build a dashboard to understand this Python 3 issue and fix in the daily business hours. Most of this issue actually is related to string encoding or string and integer comparisons. As of today, we already successfully migrate all our DAG from Python 2 to Python 3. And we found that some of the DAG loading time actually is higher in Python 3 compared to Python 2. And by doing so, we cherry pick a few performance improvement patches from upstream to help to solve it. Lastly, what we are currently working on is the Airflow upgrades. So we have two clusters. The new cluster is multi-tenants. So different users could bring their own DAG repo and sync into our Airflow cluster. We leverage a lot. We want this cluster new cluster could help to leverage like new feature like DAG serialization, RBAC, potential data lineage and performance improvements. And we also want to upgrade our legacy cluster DAG repo, monorepo, into that cluster. So current status is like we just finished the upgrade because the new cluster run on Python 3. And we want to convert our existing legacy mono DAG repo as another tenants onto this new cluster. So summary. So today I'm talking a little bit about the Lyft data platform in general and covers the customization we have done for Airflow selectively. A lot of the in detail in one of my blog posts in the Lyft engineer blogs, and talk a little bit about current work we have done for Airflow and Lyft. So today I represent Lyft. A lot of works actually are done by my teams, and they are the true heroes. And also, lastly, I want to thank Maxim for his guidance during his time at Lyft. Thank you.